Hi folks, welcome back to Math with Captain Rod. The topic of today's fun is about asymptotes. Asymptotes, everybody's favorite topic. And first I want to talk a little bit about why we're talking about them. Understanding how asymptotes work and what types there are is a wonderful, wonderful graphing aid, particularly graphing functions, that have vertical asymptotes. It makes them a lot easier to graph, makes all functions easier to graph and understand. So for starters, there are three different types of asymptotes to consider. There are what are called horizontal asymptotes, then there's what are called vertical asymptotes, and oblique asymptotes, which I like to call slanters, and I'll describe why here in a minute. All right, so horizontal asymptotes tell you what the function does basically for large values of x. They're easy to find by taking limit as x goes to either plus or minus infinity. Of whatever function you're talking about, and typically you would do them, one at a time. You're going to get a horizontal asymptote when you're looking at rational functions, and again, rational functions are functions that are basically fractions of polynomials, and I've written some examples up here of rational functions here, here, and here. You're going to get horizontal asymptotes under a couple cases. Let's take a look at case one here. The top of this function is a constant and the bottom is linear. So as x gets larger and larger and larger, y is getting smaller and smaller and smaller, or in other words, y is going to 0. If you take the limit of this expression as x goes to infinity, you actually get 0 out. So y equals 0 is a horizontal asymptote. You're going to get a horizontal asymptote of y equals 0 anytime the denominator is a higher power than the numerator. So for example, had this been maybe an x up top and this an x squared in the bottom, you also would end up with a horizontal asymptote of y equals 0. Or maybe an x squared up top but an x to the fifth in the bottom also would drive that to y equals 0. Another type of horizontal asymptote occurs when the numerator is of the same power as the denominator. And again, if you take limit of this expression, and I'll do so later in the video more formally, but if you take the limit of this expression as x goes to infinity, you'll get 3 out of it. So this thing has a horizontal asymptote of y equals 3. And again, I'll go through examples in a little more formality here after I get done describing it. You will end up with a horizontal asymptote of y equals a constant anytime the numerator and denominator are of the same power. So had this been a 3x to the fifth over x to the fifth plus 1, you'd end up with a horizontal asymptote. Another type of asymptote that's extremely important are vertical asymptotes. This happens, you get vertical asymptotes whenever you have division by zeros. So looking at the examples I have up above, this one has a vertical asymptote at x equals 2. This one does not have a vertical asymptote because x squared plus 1 cannot equal 0 for any value of x, any real value of x. This one has a vertical asymptote at x equals 1. So to find vertical asymptotes, you're looking for division by zeros. Anywhere where you divide by 0, anywhere where there's a value of x where you could end up with a division by 0 should have a vertical asymptote there. Unless the factor cancels out. I mean, there are times where you'll have something in the bottom of division by 0, but something cancels it, and the asymptote isn't actually there. And again, I'll show examples of that later. All right. Another example of asymptotes are what are called oblique asymptotes, or they're sometimes called, I like to call them sliding or slanters. Here's an example of a function that's going to have an oblique asymptote. You'll notice that the top of this is second power, but the bottom is first power. So for large values of x, what occurs is this function ends up being basically linear for large values of x because the top is second order, bottom's first order. So you'll end up with oblique asymptotes whenever the top is exactly 1 power higher in x than the bottom. So these are the three types of asymptotes that can occur. And again, the purpose of this video is just to describe the three different types and when they occur. I think what I'll do is I'll make a different video here about actually finding them and using them to graph. So again, horizontal asymptotes, you take limit as x goes to plus or minus infinity. You'll get a horizontal asymptote anytime the top is the same power as the bottom. that typically will have an asymptote of y going to some constant. Or if the bottom is a higher power than the top, y equals 0 will end up being a horizontal asymptote in that case. Vertical asymptotes occur when you have division by zeros. So up here, this one's got a vertical asymptote, so does this one. As a quick example, had this been x squared minus 1, this would have two vertical asymptotes, one at plus 1 and one at minus 1. And then oblique asymptotes will occur when the top is one power higher in x than the bottom. So I think what I'm going to do here, just to keep these videos short, is stop this and go through the examples in a second video. So I hope this helps describe the different types of asymptotes. Have a great day.